In this video, I want to talk about some very special tools. One of them, once you get past the basic Nmap and pinging and poking and prodding around your network, one of the things that you can do is you can use some of the advanced pinging tools or packet crafting tools to start poking and prodding. And for this lab, what I'll do is I will basically sniff the traffic and show you how to set specific flags using hping and then verify that with, for example, Wireshark. Okay, so we'll go ahead and load Wireshark. We'll go ahead and do a Control-I to bring up our interfaces. Grab your interface with the traffic. In this case, I'm going to do my local address. You can see the packets trickling in, and I'm going to go ahead and start that. Once that's started, then I can go back to the command prompt or the bash shell and basically do a help for hping. So let's look at it. hping, hping3, tac h is for your help. And this is a pretty powerful packet crafting and scanning tool. Some of the things that you can do in the beginning are basically right here at the top. You can just get a little overview of the tool. So you got help, you've got a version, you can set a particular interval, how fast you or slow you want it to work. So, send 10 packets per second or 100 packets per second. If you want to flood the host, more of a denial service attack. If you want numeric output, if you just want your terminal to actually be quiet, you don't necessarily want the feedback sent to the terminal. Specify your interface, always your Ethernet or first interface or your routing interface as a default. And then verbose mode gives us really, really good detail. And you might not want to do the beep for every matching packet received, just because the beeps, in my opinion, get a little annoying. Next is the mode in which you want this tool to operate, and it's basically got 5 different modes. It's got your core 4, TCP and UDP, IP and ICMP, but it's also got a specific scanning mode. So if you want to look for particular ports against the target, you certainly can do that and use hping as a scanner. So it's kind of like packet crafter meets reconnaissance tool meets scanner. The next section is IP. Okay, this is where if you really know your packet analysis, you can realistically go in there and manipulate all portions of the IP packet. Everything from time to lives, IDs, Windows IDs. If you want to set fragmentation or set more fragments or don't fragments or offset the fragments, sometimes useful in defeating intrusion detection systems. If you want to alter the maximum transmission unit, and again, if you're altering that, more than likely you're probably going to use that with the fragment option as well. That also works against intrusion detection systems. And then, of course, source routing, which may or may not work, probably will, because source routing has been disabled for some time. Then you can go into the ICMP portion of the packet, IP's cousin. I call it the little police cop. And then, because it basically reports back, and if you've ever watched the video Warriors from the Net, really, really old video, basically they illustrated ICMP as a little police cop. But specifically, ICMP has types and codes, and we're always interested in them. And you can look those up anywhere on the internet. But I can tell you the most popular types and codes basically are type 8, which is an echo request, type 0, which is an echo reply, and then, of course, a few other ones like 11 and 13 are definitely in third and fourth place in there. And not to say that we couldn't have others. All right, but we can set gateway addresses, we can set aliases, we can set specific ICMP types, or basically do a help specifically for the ICMP. Then you can go on to layer 4 of the OSI model, your TCP and UDP. Don't forget, UDP realistically has nothing in the packet, and we'll be able to verify that here in just a second. And then TCP, which we can completely take apart that packet, and what we're specifically going to be focusing on today is basically manipulating the flags. Now, sometimes in a virtual environment, I do see that I get a different result with hping3. But every time I get an error or something that I scratch my head on, I typically just revert back to hping2, run the same command, except with a 2 versus a 3. And magically in the virtual world, a lot of my problems go away. But in the new latest and greatest version of Kali, you actually might have to reinstall hping2 because realistically there's no need for it. If hping3 works just fine. And then after the TCP and UDP options, you have common options which you can use for anything. For example, you can set data sizes, you can dump packets in hexadecimal later to the terminal if you want, or to a file. You can incorporate it with trace route. You can do trace route mode, ARS packet description. It's kind of a newer technique that people are still realistically learning the value of right now. But basically, that's the overview. So what we're going to do is clear the screen and basically start fresh. So let's do an hping3, and let's go ahead and set our flags. So we'll send the SYN and the urgent flag, and we'll go ahead and use that against our target 192.168.92.131. And we'll go ahead and run, and you can see that these packets are going back left and right. So to make that interesting, we also have Wireshark open, but we're going to also look at EtherApe as well, because I always want you guys to get the idea of realistically what's happening. So I'm going to try to do this again here and let you guys see this all at once. So let's go back here to our hping3 scan and go ahead and let that run. And while that's running, I'll go ahead and switch back and forth. And it's basically just going one host to the other. And it's not really that interesting. Only by the color could you realistically see what this is. But it's lightweight traffic. It's ICMP. It's just going back and forth. Actually, ICMP and TCP. So there's not really much of anything interesting, but just between these two hosts there. But just wanted to point that out compared to some of the other labs that we did. So now that I've gone ahead and ran that scan reconnaissance tool borderline attack, let's go ahead and look in Wireshark and actually see what we found. So I'm going to stop the scan, and I'm going to sort the fields. IP.dst is equal to space 192.168.92.131, which is our target. And I'm going to go all the way down to the bottom to get the latest and greatest information. Select that packet. And I'm going to take apart the TCP flags here. And what I can do here is I can actually verify that the SYN and the urgent flag actually were set in the packet as went back and forth between the source and the destination. Now that's pretty cool, because it's one thing to do something, it's another thing to tie it into actually seeing it, and then we change it from actually seeing it to sniffing the traffic and actually looking at it. So let's go ahead and kind of just zoom out just for 1 second here. Now in this sniffer, Wireshark, we've got all of the layer 2 information here, we've got all of the layer 3 information, and then all of the layer 4 information. Now, specifically, I want to kind of match what you would have saw in the hping client in the help file to actually what's actually in the packet. So here's our header version, which is in this case IPv4, so it's always going to be 4. The header is always 20 bytes. You've got the differential services field. You've got the total length. I've got the flags. In this case, it's IP flags, so it's the basically the fragment and the don't fragment, which corresponds into hping. The offset field, the upper layer, layer 4 protocol that it's handing off to, and this is TCP at 6, and then the source and destination, if there's a GeoIP, if it's on a public network, and then that's basically it. So you can see the manipulatable fields right here from the sniffer. And then go ahead and expand TCP, and you can see the source port, the destination port, the sequence numbers, relatively speaking, the acknowledgements. You can dig this apart and kind of get a better feel for what this does. So you can see broken TCP, the acknowledgement field is non-zero. Okay, you can see the different flags, which I just showed you, and also the value here. I'll show you how to use this in a later video, but this value here is also of significance because you can write Wireshark filters on that value field here, or the flag in itself. The window size, and then the actual checksum. In this case, the validation is disabled. Now, this is good, especially if you want to defeat certain intrusion detection systems. If you can turn these checksums off, or specifically turn them to true, then certain appliances that read traffic assume that they're valid and then will leave them alone because they've been unchanged, as opposed to something like false. And that's basically the overview of what would be in the TCP packet. So what I like to do in this case, just to recap here, is I like to actually look at the actual hping command. In this case, we did an hping with the SYN and the urgent bit set to a destination. I captured that from the client to the server, and I was able to analyze that using a packet sniffer and actually verify and validate what I set in the packet was actually in fact set. So I'm not making this up. This is exactly what goes across the wire. And I could literally do this per packet. If I wanted to, one of the tricks you can do is if you just leave this open down here and then select on your packets here and then zoom in on the actual flags or whatever part you want. If I scroll through this at the top now, I can see if there's any packets with this information changing. And I'm basically just scrolling through. And you can see that every time that I captured something in here, all of the SYN and the urgent bits were set. And so that proves that basically I captured the specific traffic that I was looking for. I also could have done the same thing with T-Shark, which is another command line terminal Wireshark version. I could have done the same thing with TCP dump, or actually several other sniffing tools, whether it be third party, Kali, or command line. It really doesn't matter. All of it's verifiable depending on how much detail you realistically want to interrogate the packet. So there's many lessons to be learned here. 1, scanning tool. 2, verifying with a packet sniffer, and 3, getting very, very intimate with the sniffers and the packet layouts, because the best way to learn this stuff is to realistically watch it and learn from the results of what you're seeing. Let the computer tell you what it's doing, and then you realistically don't have to think about it too hard. So practice, practice, practice. I'll catch you in the next video. My name is Leo Dreger. Thanks for watching, and don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter.